Hi guys, Mr. Mackey here. Now yesterday we were adding and subtracting fractions from each other. So I set you with this problem last night. 5.5 minus 2 and a sixth. So let's get cracking on with it so we can start today's fun activity. So what we do when we have these is we first get rid of the whole numbers. And we do that by doing 5 take away 2. 5 take away 2 gets us 3. So I put that 3 down there and I'm going to get rid of these two whole numbers. So now we've just got the fractions, a half minus a sixth. Do you remember what we do when we do these? We ask ourselves, are the denominators the same? No. How do we make them the same? Well, we can turn this 2 into a 6 by timesing our denominator, the bottom number, by 3. But we have to also times our numerator, our top number, by 3. So 2 times 3 gets us 6. 1 times 3 gets us 3. Now our denominators are the same, so we can get on with it. 3 over 6 minus 1 over 6 equals 2 over 6. Remember, because the denominators are the same in the problem, they'll be the same in the answer. Can this 2 over 6 be simplified? Yes, it can. They're both in the 2 times table. So we simplify that. How many 2's going to 2? 1. How many 2's going to 6? 3. Now this is a bit that I'm sure many people might have got stuck on. So we've got what happens when we take away the two whole numbers and what happens when we take away the two fractions. We've now got to put those answers together. And when putting them together, we are adding them. So it's 3 plus 1/3. So with our 3, we must turn that into a fraction. So we draw a line here and 1 underneath. And now we can add them together. Are the denominators the same? No. How do we make them the same? We times them by 3. So 1 times 3 will get us 3. 3 times 3 will get us 9. Now we can add them together. 9 and 1 equals 10. We keep our denominator the same. But this is an improper fraction. How many 3's go into 10? Well, let's see. 3, 6, 9, 12. 12 is too far, so it only goes in 3 times. 10 was the number we got to, but we reached 9, so we have a remainder of 1. And we keep our denominator the same. So the overall answer is 3 and 1/3. So in today's video, we're going to be multiplying and dividing fractions with each other. Now multiplying and dividing I always see is easier than adding and subtracting. You may disagree. Let's see how this video goes. So 4/5 times 3/7. Here's how you do it. It's pretty simple. Does it matter if the denominators are different? Not in this case. Because all we have to do is we times our numerators, our top numbers together, and we times our denominators, our bottom numbers together. So what's 4 times 3? If you do a 4 times table or a 3 times table, you would get 12. What's 5 times 7? Well, if you do your times tables, you will get 35. Can this be simplified? No, so we leave it as that. So let's try another one. 8/9 times 3/4. We times our numerators, our top numbers together, and our denominators, our bottom numbers together. What's 8 times 3? Well, if you do your times tables, you will get 24. What's 9 times 4? Well, again, times tables, you will get 36. Now, can this be simplified? Well, they are both in the 2 times table, so we can simplify it to 12 over 18. But this could be simplified further. It's again in the 2 times table, so that could get us 6 over 9. But now this is in the 3 times table, so this can be simplified further to 2 over 3. That was a lot of simplifying. Is there a little trick to make it quicker? Yes, there is. Let's rewind back to the start. Now obviously it is okay to simplify. The method I showed you is fine because you will still get the right answer. But there might be some cases where you're not sure whether you have to simplify or not, And if you have to do it a lot of times like I did, it might become a bit tedious. This method means you don't have to simplify at all in your answer, and it's called cross multiplying. Let me show you. What I do is I extend the time symbol like this. And now we look at the numbers opposite to each other. So let me show you what I mean. 8 and 4. Do they have anything in common? They're both in the 4 times table. How many 4s go into 8? 2. How many 4s go into 4? 1. How about 9 and 3? How many 3s go into 9? 3. How many 3s go into 3? 1. So we have just simplified the problem for us. What's 2/3 times 1 over 1? Well, what's 2 times 1? 2. What's 3 times 1? 3. Now this trick are for people who are not sure whether they need to simplify or if they're thinking it'll take too long to simplify. This makes it a bit quicker. You don't have to do this trick. You don't have to know this trick. It's just a nice little bonus to get you through the day. But of course, if you're not sure or you don't feel confident on this trick, then by all means, go with the first method. This is just a free choice. What about when we're faced with a problem like this, when we have a mixed number fraction? Mixed number means that when we have a fraction and a whole number put together. So, in most cases, when we deal with stuff like this, we separate the mixed the number and the whole number. But for multiplying and dividing fractions, we're going to do something a little different. What we're going to do is we're going to turn this into an improper fraction. This is how you do it. Now, 2 means that there were 2 wholes of fractions in this. So what we do is we times that 2 by our denominator. We times the 2 by the denominator, which is 4. What does that get us? 2, 4, 6, 8. So we times them 2 together. Then we add that result to our numerator, the top number. So we got 8 and we add that 8 to the numerator. And that will get us 9. When we do that, we move our 2. That's gone. So now we're doing 9 over 4 times 3 over 8. So now we times them together. We times our numerators together. What's 9 times 3? 27. What's 4 times 8? 32. Do we need to simplify? No, we just keep it like that because there's no numbers that go into each other. And see, once you get through the hurdles of the mixed numbers or the improper fractions, multiplying fractions is no different to any other problem. Fantastic. Finally, what about problems like this? 12 times 5 over 6. We haven't got a mixed number, we haven't got an improper fraction, we've just got a whole number. What do? Well, we do the same thing what we did with addition and subtraction. We turn that 12 into a fraction. What we do is you put a line here and a 1 underneath. Now we can times them together. We can get on with it. So, what is 12 times 5? Well, that becomes 60. What's 6 times 1? Well, 6. Can this be simplified? Well, they're both in the 6 times tables. How many 6s go into 60? 10. How many 6s go into 6? 1. And what's 10 over 1 the same as? 10. Whenever you're given a fraction like this, I always urge you to leave it as a whole number. Because it was left as a whole number at the start, so we should leave it as a whole number at the end. So now that we've done enough multiplying fractions, let's try some division. 3/4 divided by a half. Now there is a really cool trick whenever we're faced with a problem like this. And it is KCF. Now what does KCF stand for? Well, let's use it for this problem. The K stands for keep, as in we keep the first fraction the same. Change is what the C stands for. as in we change our division sign into a times. And the F stands for flip, where we flip our second fraction so it's opposite. Now we have a multiplication problem. 3 over 4 times 2 over 1. And because we did a lot of multiplication early on in the video, you could be able to do this one just fine. 3 times 2 is 6. 4 times 1 is 4. Can this be simplified? Yes. 3 over 2. So let's try another one. 5 over 8 divided by 5 over 6. We're now going to KCF it. We're going to keep the first one the same. We're going to change the divide into a times. And we're going to flip the second fraction. Let's do it. So now that we've done it, let's get on with it. What's 5 times 6? Well, that will get us 30. 8 times 5, that will get us 40. Can this be simplified? They're both in the 10 times table, so yeah. So how many 10s go into 30? 3. How many 10s go into 40? 4. And that is it. So what about a problem like this? 2 1/3 divided by 3 1/2. Firstly, we have to convert both of these into improper fractions. Remember how we did it? What's 2 times 3? That gets us 6. We then put that 6 on top of our numerator, the top number, turning that into a 7. And that gets rid of the 2. What's 3 times 2? 6. Put that on top of our numerator, turning that into a 7. That gets rid of the 3. So now we can do our KCF. We keep our first fraction the same, we turn our divide into a times, and we flip the second fraction. Let's do this. So now that we've done it, let's get on with it. 2 times 7 is 14. 3 times 7 is 21. Can this be simplified? Well, they're both in the 7 times table, so yes. How many 7s go into 14? Well, twice. How many 7s go into 21? Well, 3 times. The answer is 2/3. Now, I feel I've gone through a lot of multiplication and division questions today, but I've not gone through a question where you have to do both. So in this question, you do 5/8 times 2/5, and then you divide the answer by 1/3. That's what we have to do. But I'm not going to do it. This is your challenge for today. I want you to solve this problem for me. You do 5/8 times 2/5 and then divide that whole answer by 1/3. We'll go through it tomorrow. It's been this has been one of my favourite topics, and I hope that you have learned something from today. And it's important that you do learn stuff, because that is the whole point of this channel. Even though that there are millions of children at the moment stuck at home, they are still getting a good education, and I hope this is helping towards that. I'm doing my best to help, so please do your best and share this channel. Tell everyone you know about this, because we need to keep our children learning. Thank you. Good luck.